Hello, my amazing students. This is Mrs. A, and I love math. And I hope that in listening to me teach you that you will learn to love math as well. So what I'm going to be doing is I'm going to be teaching out of this book, which is Saxon's Algebra 1/2. This is the second edition, but my granddaughter, who is the one that I am teaching this for first, hello Hannah, she has a third edition book. So what I'm doing is I'm comparing the second edition with the third edition and making any adjustments that I need to. So these videos should pretty much go for either one, the second or the third edition. So with that short little introduction, I hope that you will join me. This is fall 2019, and because my granddaughter Hannah is needing me to teach her these concepts, I'm going to be doing it all through the school year and keeping up with the school year pace. So we're going to be doing lesson 1 today because her first day of school is tomorrow. And I need to have lesson 1 ready for her. So if you are jumping on to enjoy Algebra 1/2, which is the equivalent of pre-algebra, with me, welcome. And I hope that you will enjoy our math journey. This is Saxon Algebra 1/2, lesson 1. And we're talking about our number system. And we need to know what our number system is all about so that we know how to use numbers and what they mean. And our system is the Hindu Arabic number system. We don't use Roman numerals, we use Hindu Arabic numerals. And the digits that we are familiar with are 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and those 10 digits make up every number possible. And the reason they make them up so nicely is because we adhere to this place value system. And once we learn the place value system, then we can recognize any number. So this is my decimal place, and sometimes you see the decimal place and sometimes you don't see the decimal place, but the decimal place is always there. It separates our whole numbers from numbers that are parts of numbers, which we will talk about later. So today we're only talking about whole numbers, and this farthest to the right spot is the ones place. And then we have the next spot is the tens place, and the hundreds, and the thousands, and the 10,000s, and the 100,000s, and then I ran out of room. But what's after the 100,000s is the 1,000,000s, which is also called the millions. All right, so we usually, when we write our numbers, we will start the decimal and we will count 1, 2, 3, comma, because it's just a way of helping us keep track. The number names change every comma, don't they? So here, right after the comma, 1, 2, 3, comma, then we start the thousands. And then, like I said, we had the thousands, and then the 10,000s, and then the 100,000s. And then 1, 2, 3, we put another comma. And I don't have a spot, but the next one would be the millions. Okay, so each time we have a comma, we change the name. And then we would go thousands, and then millions, and then 3 more, we'd have billions. And 3 more, we'd have trillions, and on and on and on. Okay? So, numbers are really cool. We have what's called a base 10 system. Now, base 10 means that every digit is 10 times the digit that comes to the right. So, basically, every spot. So, the tens place is 10 times the ones place. And then the hundreds, this place's value is 10 times this place's value. And then the thousands place is basically 10 times 100. And the if I multiply the thousands place by 10, then I get 10,000. And then the 10,000s place, I multiply that by 10 and I get 100,000. And those are getting really big numbers, but they just keep on getting bigger and bigger and bigger. But the ones that we really want to concentrate now are going to be, you know, thousands and then millions and billions and trillions. We probably won't go past that because it gets really big and cumbersome. But our number system is designed to go as far as we want to go. Here is example 1, and we have this number here written for us, and if we were going to read that number, which is the next section, we would say it's 46,235. What is the value of the digit 5? So if we were to make our little places, then we would call this one the ones place or the units place. We would call the one that has the 3 the tens place. The one that has the 2 is the hundreds place. The one that contains the 6 is the thousands place. And the one that contains the 4 is the 10,000s place. So even though the digit is a 5, the 5 does mean 5 ones. So the value of the digit 5 is 5. Okay, so the value of the digit 5 is 5. The value of the digit 2, well, the digit 2 is in the hundreds place. So it's 2 times 100 or 200. So the value of the 2 is actually 200. Okay, and then the value of the 4, well, the 4 is way over here in the 10,000s place. So 4 times 10,000 is 40,000. So that 4 really means 40,000. So we're going to be working a lot with numbers in this section and understanding what they mean. The next little section in your book is about how to write a number. So any number that's between 20 and 100 is going to be hyphenated. So we're going to take the word like 23. When we write 23 out, it's going to be 20-3, 70-9. So any number that's between 20 and 100, we hyphenate when we put in the number. Unless the number ends in 0, like 20, 30, 40, and then it's only one word anyway, so we don't hyphenate it. So it's really an easy rule to remember. Here is another pretty easy rule to remember. If we use 10 million, we don't hyphenate it. But if we use 10 million to modify another word, like the 10 millionth digit, then we would hyphenate 10 million. So we only use the hyphen if our number is modifying digit or place or something else. So when we just say 10 million, we don't use a hyphen. So that's something new. So in this one, we have a comma and another comma. And remember the units, ones, tens, hundreds, this whole little area there is the thousands, because this is 1,000, 10,000, 100,000. And then when we start this one in here, everything that's between here and the next comma, which we don't have, is millions. So now, and this is at the bottom of page 2 in your book, they have this all down a very long number line, which I will show you in a minute. But we're going to start at 51, and then we're going to stop at the comma and say millions. So 51,723,642 would be how to read that number. Notice there were no ands. We never say and until we read the decimal point. And this one, the decimal point is not really going to be read because we're only talking about whole numbers, not pieces and parts of numbers. So that's how we're going to read it. And this is how we would write it. 51 million, notice 51 is hyphenated, 723,000, and the 23 is hyphenated, but not the 700. And then 642 is going to be hyphenated on the 42, and that would be the number. Notice how easy that is. Every time we hit a number here, a comma here, we're going to have a comma in our written word too. So 51 million, comma, 723,000, comma, 642. Now we have an example, 1.3 here, and it tells us to write this word, this really big word, into number form. So 51 billion 27,520. So what I like to do when I'm writing a really long number is start with a framework. So I know that these are ones, tens, hundreds, comma. This whole region in here is going to be my thousands. And then in here, after thousands, is going to come millions. And then finally, this last one over here is going to be billions. So I know that I have enough spaces because I have 51 billion. So I just made my little framework here. So now we know that this is billions, this is millions, this is thousands, and then this one is before 1,000. This goes up to 100. So now 51 billion would be way over here, wouldn't it? So 51 billion 27,000. What did they skip? They don't have any millions. Billions is way over here. Millions is right there. Thousands comes here. So what we're going to do is skip all the way over the millions and write 27,000. Well, 27,000 will be right there. 27,000. 520. 520. And guess what? Everywhere we don't have a number, we must fill in a 0. And when you're first starting to do numbers like this, having a framework so that you don't jump straight from billions to thousands is probably a pretty good idea. So let me let you see that up close. Make a little framework that's going to take you all the way up to the top number that you need, so you know how many spaces, and then fill in zeros for every one that's not mentioned. That works really nicely. Here is a number that's written in expanded form. So 4 times 10,000 plus 6 times 100 plus 5 times 1. That's expanded form. Now, how do we get from expanded form into regular numeric form? So we're going to say, basically, it's an addition problem, but you will often see they don't take the time to add them together. But it's going to be 40,000 because 4 times 10,000 would be 40,000. So 40,000, 6 times 100 would be 600, and then 5 times 1 would be 5. And now we have each one of the places written in their spot when we add them together. But if we had started with 4 times 10,000 and we had done it the other way, then we could have said, okay, what I really have here is, squeeze 3 digits in there, okay, is I have a 5-digit number because my largest value over here is 10,000, which is 5 digits. So I could start with 5 digits and say, okay, 4 times the 10,000 is going to be 40,000, and then 6 times 100 is going to be 600, and then 5 times 1 is going to be a 5, and we put zeros anywhere. We did not put a number, a different number. 0 is a numeral, isn't it? Now we're writing a number that is in standard form, into expanded form. So this is the next example. And when we see a number that is looking like a regular number, that's standard form. And then when we see all of this, it's expanded form. And we don't usually have to do this for a really long time. What they're trying to do is teach you place value. So don't get discouraged. These are long problems, but they don't hang around very long. After a little while, you just know them and you don't have any more problem with them. So we start with 6 times, and then the place that it's in is the millions place. So 6 times 1 million plus 3 times 100,000 plus 5 times 1,000 plus 1 times 100 plus 2 times 10 plus 6 times 1. Whew, look at all of that. So that is writing a number that is in standard form into expanded form. The very last section of the first lesson, we're talking about the terminology used to name these parts of an addition problem. So when we're adding them together, the individual parts are called addends, and then the total is called the sum. When we finish adding them together, the answer is called the sum. So addend, forgot my plus sign, and then sum. Then at the very bottom, they're showing you how to line up numbers. So if we're going to take a number problem like this. This is a horizontal problem. When we're going to do the problem, we will usually write it vertically. We always will right justify all of the digits because all of our numbers start with a ones place or a units place. So 4 means 4 units, or 4 times 1. 407 has a 7 in the units place. So we're going to write it so that the 7 units lines up with the 4 units from the first number. And then this one has got a thousands place, so we're going to have to move 1 more, and we'll start 6, 2, 5, 3. Now you don't necessarily have to write it backwards like that so that you start with a 6, but you do have to line up places. And if you have trouble seeing those places, sometimes it's easiest if you actually get some graph paper or something to line your columns up, or you can even visually make some little lines as you need to, but it's very important that you line them up. So 4 plus 7 plus 6 is going to be 17. We're going to carry it up there. 1 plus 0 plus 2 is 3. 4 plus 5 is 9. 3 brings down, and our answer is 3,937. Here are some practice problems down at the bottom of page 4. So here we have a number, and we're supposed to tell them the value of the numeral 2, or the digit 2. Now, one of the things they haven't done for us is they have not put any commas in. You will often see numbers that don't have commas. The commas are there just to make the number easier to read. So we're going to go ahead and put the comma. 1, 2, 3, comma. So now we know the 2 is right before the comma, so the 2 is in the thousands place. So the value of the 2 is 2 times 1,000, which is going to be 2,000. Now let's look at B. And in B, they asked me to write the standard form of this expanded number. So 6 times 1,000 is going to be 6 in the thousands place. So since my largest place value is thousands, I can go ahead and make a little skeleton here if I want to. And so I'm going to have 6 in the thousands place. I'm going to have 4 in the tens place, which is right here. And I'm going to have a 3 in the ones place. And I'd better give a 0 where I am missing a spot. So the number is 6,400. 43, which is the same thing that I would get if I wrote them all vertically and added them together. So I could say 6,040 and 3, and when I add them all up together, don't I get 6,043? All right, so we have example C, or practice problem C and D. On this one, it tells us to write this standard form into expanded form. So everywhere we see a digit, we're going to have to do something. If we see a 0, a non-zero digit, we have to do something. A 0, we just sort of ignore, skip over, because we don't have to write anything. So 8 is in the 10,000s place, so 8 times 10,000. 5 is in the thousands place, so 5 times 1,000. We skip over the 0, and then 2 is in the tens place, so 2 times 10. So this would be all we would have to write it in expanded form. So now we have a big number because it goes all the way to billions. And then we're going to write this number out in digits. So I'm going to make my little skeleton here. So we're going to have units, ones, tens, hundreds, thousands, put a comma, thousands, 10,000s, 100,000s, put a comma, okay, millions, 10 millions, 100 millions, comma, and then billions, and then 10 billions, because look what we start with, 10 billion. We need all of those little spaces to either hold a numeral that's not 0 or 0. Every one of them has to be accounted for. So let's start. Now that we've got our nice little framework here, let's start with 10 billion. So we know that when we get to billion, we have the comma. That's all that's in that little segment. So 10 is just going to be 10 billion, way over there. 205 million. Okay, well, millions is the next spot. So 205 million. 41,000. So here we're in the thousands little area here. 41,000. So 41,000. We skipped this one so we can fill him with a 0. 500. 500. So those are examples or practice problems C and D. This is the last practice problem, and it is number or letter E. So here we go. There's our number in standard form, and we are to write it into its word form. But notice that we have no commas. So let's go in and put our commas, because it certainly helps us to keep straight on where we are in a number. So we'll start here at the decimal. We don't see the decimal, but we know it's there. So we're going to count 1, 2, 3, comma, 1, 2, 3, comma. So we have 36,25,103. Now that is the last little bit of lesson 1. Now I don't want you to get, this one was kind of long. They do get shorter. The lessons get shorter. The first lessons in the Saxon book are a little bit longer because they're explaining a lot of terminologies to you that we will be using as we go. So first few lessons are kind of lengthy in the teaching because we're doing a lot of concepts that will follow you throughout the year. So don't forget, this is Mrs. A, and may God bless your day.